All right, today we are diving deep into one of the most mind-bending ideas at the very edge of physics. We're going to explore a truly radical theory about where everything, and I mean everything, from the tiniest particle to space-time itself, might actually come from. Okay, let's get right into it. So I want to start with a question that gets right to the heart of this. Just think about this for a second. What if the fundamental building block of our reality isn't something orderly, but just pure, untamed chaos? What if everything we see and touch is just a stable pattern that somehow managed to rise up out of an infinite, restless sea of possibility? Now, to even wrap our heads around that, we kind of have to throw out our everyday intuition. Our classical view is that empty space is, well, empty, nothing there. But quantum physics paints a totally different picture. It tells us that empty space is actually a seething sea of energy, a place buzzing with constant activity. It's not a void at all. It might just be the most fundamental something there is. Okay, so this energy of nothing, it actually has a name. And this is where our journey really begins. We need to get to know something called the zero-point energy field. So what exactly is zero-point energy? Well, imagine you could cool a system down to absolute zero, the coldest temperature theoretically possible. Even then, there's still a tiny bit of energy left over. That's ZPE. Thanks to the uncertainty principle, quantum fields can never be perfectly still. So, the ZPE is like the universe's constant background hum, an energy that can never, ever be turned off. And here's where the idea gets really wild. According to this theory, the ZP isn't just some random leftover noise, it's the universal substrate. Think of it like the ultimate cosmic clay, the fundamental raw material from which every particle, every force, and even the fabric of space-time could be sculpted. Okay, so if zero-point energy is the raw material, what's the architect, right? How do you get a complex, ordered universe from all that chaos? Well, that brings us to the second big piece of the puzzle, a framework called Constraint-Resonance Emergence Theory, or just CRIT for short. CRET is basically a set of instructions for building a universe. It's a theory all about emergence, the idea that complex things, like the space-time we experience, can arise from way simpler, microscopic layers. And the key is that these layers are all connected by a dynamic feedback loop. It's a bottom-up approach to cosmic construction. So CRET organizes reality into three connected layers. Way down at the bottom, you've got the microdynamics. Think of them as the tiny little pixels of reality, maybe something like Planck-scale qubits. Then you've got the mesostructure, which is the intricate web of connections, the quantum entanglement between all those pixels. And finally, those two bottom layers work together to create the macro constraints, the smooth, large-scale reality that we actually experience, complete with space-time and gravity. But here's the kicker. It's not a one-way street. That's the magic of this feedback loop. You have upward amplification, where all the tiny fluctuations at the micro level add up to create the large-scale geometry of space-time. But then you get downward selection. That new space-time geometry actually feeds back down and sets the rules for the micro level, deciding which patterns are allowed to exist and which ones aren't. It's a system that builds and governs itself. Pretty wild, right? So, how does this feedback loop actually work? How does it pick and choose which stable patterns get to survive out of that chaotic soup of zero-point energy? The secret ingredient, the key mechanism, is a concept we can all understand: resonance. And to really get this, let's use a simple analogy that we can all wrap our heads around. Forget quantum physics for a minute. Just picture a guitar string. When you pluck it, it can vibrate in all sorts of messy, chaotic ways, but only certain vibrations actually last. These special, stable patterns have a name. They're called eigenmodes. On our guitar string, these are the clear, beautiful musical notes, the harmonics. All the other messy, chaotic vibrations just cancel each other out and fade away almost instantly. But the resonant frequencies, the eigenmodes, they stick around. The string itself acts like a filter for chaos, leaving only order, only music. Okay, now let's map this analogy directly onto the universe. The chaotic, random vibration of the string, that's like the random fluctuations of the zero-point energy field. The physical limits of the string that create the notes, those are the resonance constraints from that CRET feedback loop. And the result? Those stable musical notes are the universe's version of stable elementary particles. The idea is that particles are just the resonant notes of the quantum vacuum. So let's put it all together. We have our raw material, the ZPE, and we have our architectural plan, CRET. When you combine them, You get this speculative, but incredibly elegant origin story for, well, for everything. This quote from the source material just nails it. What we call matter, the fundamental particles like electrons and quarks, might be nothing more than these stable, standing waves, these allowed eigenmodes that are able to persist inside the chaotic medium of the zero-point field. Think about that for a second. A particle isn't so much a thing as it is a stable vibration, a note that's allowed to be played. And this connects everything back perfectly. Remember those fundamental pixels from Crate's bottom layer? This theory suggests they are these standing waves. The most basic building blocks of reality aren't tiny little points, but fundamental vibrations, stabilized by resonance. And it gets even bigger. It's not just about particles. This is where it goes to a whole new level. Gravity itself, the curvature of spacetime, is also proposed to be an emergent property. The quote says it's the self-maintaining shape of this cosmic resonance. In other words, gravity isn't some separate force, it's just the overall shape of the universe's ongoing song. So to recap the whole picture, you have the source, the zero-point energy field. That's our chaotic cosmic string. You have the mechanism, Constraint-Resonance Emergence Theory. That's the tuning that filters the chaos. And you have the result, the stable particles and the very fabric of space-time that make up our universe, the music. Now, as absolutely beautiful and all-encompassing as this idea sounds, we have to pump the brakes for a second. We have to do a crucial reality check, because this is an idea living on the absolute edge of what we know. And I really can't say this strongly enough. This is a speculative and unproven framework. It is absolutely not established textbook physics. It's a fascinating and compelling what-if that some physicists are exploring, but it is still just a hypothesis. And the challenges it has to overcome are massive. I mean, to be taken seriously, it would need to predict the exact masses of the particles we see. It would have to perfectly reproduce these super specific mathematical rules that our forces follow. It still needs to tell us what this underlying medium really is. And right now, we don't even have the physics to begin to test or verify it. But that's what science on the frontier is all about. It pushes us to ask these giant questions. And this idea leaves us with a truly profound one to chew on. If our entire reality is just one set of stable resonances, one beautiful chord being played on a cosmic instrument, what other frequencies, what other songs might the universe know how to sing? What other music is out there, just waiting for us to figure out how to listen?